that this NISAR is not our own indigenous satellite. Remember one thing, this NISAR is not our own indigenous satellite. Actually, it was prepared by NASA. Do you know NASA? Do you know NASA? Okay. Do you know NASA? Where is it? Come on, try to respond. Huh? Yeah, it is in the world famous country called America. It is ruling everywhere. Okay, huh? So NASA is, what is meant by NASA? NASA is nothing but National Aeronautic Space Agency. National Aeronautic Space Agency of America, which looks after all the satellite launching operations of America. This NASA prepared a satellite, but due to various reasons and technical problems, they are unable to launch it from the Earth of America. From the platform of America, they are unable to launch it. Henceforth, they seek our cooperation. They seek the cooperation of ISRO in launching this. It is what you call a very pride factor for us. A country made its own satellite, but it is unable to launch. See, being an advanced country, top country in the world rather, isn't it? America only top now. Any other country is there? America only top now. Even that country is setting back in launching this. They seek our cooperation, our ISRO, a pride factor of India, a jewel of India, ISRO. They seek our cooperation. So it is a joint collaboration of our ISRO and NASA. The first name, first letter in NASA. What is the first letter in NASA? N is the first letter in NASA. Okay? As the same, I is the first letter in ISRO. By taking these first and second letters, and it proceeds like this. So this is the mystery behind keeping the name of this satellite as NISAR. Okay, got the point now? Got it? Why it is called as NISAR? It is called as NISAR because it is a joint collaboration of our India, ISRO and NASA. As it is a joint collaboration, a joint name has been kept for this NISAR, for this NISAR satellite. Like this, the name NISAR has been kept for this satellite. This NISAR satellite chiefly meant for capturing the data on the Earth. I think you will be knowing how many months will be there in a year? 12 months will be there. Again, in 1 month, there will be 2 fortnights, 15 days. Okay? This NISAR satellite able to capture the entire data. This NISAR satellite is there. This NISAR satellite is to capture the data every fortnight. Every fortnight. That means within 15 days, it captures entire world's data, entire Earth's data rather. So for that purpose, it has been sent into the space recently. I think perhaps last month, in the month of August, it has been successfully launched. One can see that AV also. I will say that AV also. Okay? So this is about the beginning. My aim here, by giving this PowerPoint presentation, just to inculcate the awareness and at the same time, just to enlighten the masses and create a matter of interest towards research and organization. For that purpose, it has been meant. Okay? Next, click. You can see the spectacular launching of a satellite here. You can see on the AV which is played on the screen, the spectacular launching of a satellite. A satellite has been launched here. How the satellite has been launched? What are the stages in launching a satellite? What are the primary requisites? What it has to overcome? Remaining all such facts one can have in the due course of this symposium. Okay? It is not that much well and good to give all the information at once. Finally, I will provide the information. I will provide information. Panoramic view, how the fumes, what you call thirsted gas releases. As the thirsted gas releases, we can see the rocket is going up. The AV, in the AV, you are not what you call watching any satellite. Is it a satellite? Is it a satellite? In the due course, you come across whether is it a satellite or not. I will promise you, I will make sure to load you people, to enlighten you people, whether is it a satellite or not, what is called as a satellite, and what is this one. These all things you come across in the due course. So it is a panoramic and beautiful view of launching a satellite. Just to enlighten you, I played this AV. Next slide, please. Okay. Now we can see the actual spectacular landing of launching of this NISAR satellite. This is the AV. This is the audio visual of spectacular launching of NISAR satellite. Earlier shown was a particular satellite, but it is the satellite which has been launched. One can see the rocket is skying high. One can see the rocket is skying high, and one can see the payload is putting the satellite into the orbit, and some of the chambers were separated. See, one can see the separation of the chamber. Separation of the chambers. These all things will take place in the due course. Here one can beautifully examine, one can have the clear view. The separation chamber has been separated and the satellite has put into that. So it is a festive mode in our ISRO scientists. One can see the happiest moments along with ISRO. Now it has been separated. One can see NISAR separation. NISAR separation. One can see here it is a festive mode. They are congratulating themselves on the greater success of this NISAR satellite. It has been launched successfully. They are celebrating this occasion. They are celebrating this occasion. So like this, the phenomenon will go. One can see just now, one had seen this peculiar presentation of NISAR launching. NISAR launching, which is aimed to capture the data from the Earth in a very fortnight. That was the spectacular landing of what you call NISAR satellite. I just take a moment. Okay, children, there is what you call there is a communication gap between me and the operator. Okay, so kindly wait for this for moments. Children, do you know there are vivid branches of physics? We learn physics, but physics is not so one branch. There are various vivid branches of physics for there. Next please. Next please. In fact, accurately speaking, literally, the science, physics, its scope found to be very small. Its scope found to be very small. But within which, next slide. But within which it's an ocean. The scope of the branch of science, physics, is found to be very small. But within which it's an ocean. Let me come from the grassroots for better understanding. Physics has been classified into a past given. Okay. Physics has been classified into various branches, isn't it? Classified or not? Any guesses were there how physics has been classified? Can we guess anything? Any guesses were there? Any guesses? How physics has been classified? Anybody knows? Anybody, if you stand, I will pass this mic to him. Raise the hand. Politics will, in the year 1897, there was a scientist by name J.J. Thomson. J.J. Thomson. He invented a minute subatomic particle called, what is that word? Electron. When one electron was invaded to the world, then it changed the history. We can call the invention of electron as a paradigm shift. We call the invention of electron as a paradigm shift in the history of physics. Why? Because after the invention of electron, a new branch of physics has been generated, which can be read under the name as modern physics. Modern physics. Whatever read earlier, that is called as classical physics, or old physics we will call. Commonly they are called as old physics. When once the invention of electron has been taken place, which was invented by J.J. Thomson in the year 1897, that is just the beginning of the 20th century, he changed the history of physics, history of science, and there were many routes were founded. Many routes were founded. So like this, the science which is developed after the invention of the electron is called as modern physics. Is called as modern physics. Under this modern physics, what we study? A name is there. Microphysics. There is a contradiction here. Earlier we studied macrophysics, isn't it? Now it is micro. Well, children, let me give you one tip here, which will be highly beneficial when once you learn. Many things, many words, more terminology in physics is self-explanatory. Need not to get up. Need not to get any idea of it. Name itself suggests about. Only you have to remember that. We come up with two things here. One is micro, another one is macro. One is micro, another one found to be macro. One is micro, another one found to be macro. Macro is the thing studying about a bulged thing, a heavy object, that is called macro. And you will be pretty knowing what is micro. Is it a bulged thing, heavy thing, or a small thing? Yes. It is pretty known to you that in the microphysics, after the invention of the electron, modern physics has been developed. Under this modern physics, we study about microphysics. That is, microphysics studies the microscopic view of the object, whereas macrophysics studies about physical and measurable properties of the object, which can be seen, which can be learned, which can be observed by the naked eye. Can anybody see the electron? Is there anybody who watches the electron? To which extent I have to go down, to which extent I have to move high in presenting the scenario. Anybody is there? Okay.
Physics is classified into five.
Come on.
Five.
Five. Okay. What are those five?
Quantum physics, mechanical physics.
Okay.
Microphysics.
Huh?
Microphysics.
Okay.
That's all I.
That's all. Okay. It is a wonderful response I had. Give class. Various branches of physics. Physics has been classified into, next slide please. Here one can see the entire classification of physics. Whatever we read under the name of physics has been classified into two eras, two main eras. One arrow mark is given. One side one can see classical physics, towards right, towards left one can see the modern physics. The basic earliest classification of physics is nothing but in the ancient times, when the physics has been generated as a science, what we call earliest, grassroots, basic, most fundamental classification of physics is nothing but classical physics. Whatever we learn, we are learning under the heading of classical physics only. Now a question arises. What does this classical physics? What is meant by classical physics? A doubt arises, isn't it? So classical physics is that physics which studies about, just below that one can find one name. What is that one? What is that one? Not visible. Just classical physics, we come across one word there. What is that one? Huh? A little bit aloud. We call it as macro physics. What is meant by macro physics? Macro physics is a sense which studies about the physical structure of a body and an object. Which studies about physical and measurable properties of the object. That is called macro. That is called macro physics. In another sense, in the ancient times, physics, that too classical physics, is restricted to study only the elementary concepts of an object or a body, such as its mass, volume, inertia, like these elementary things. This is called as macro physics. For this reason only I said that scope of the physics found to be very small. Scope of the physics found to be very small. But within which it's an ocean, my dear, within which this physics found to be a ocean. Under the heading of microphysics, we used to read accurate definition. It is a complex term. One can define like this. Physics is, macrophysics is that branch of physics which studies about physical and measurable properties of the object. That means those properties which are visible to the naked eye. One can perceive these properties by taking this visibility. Okay? Like this, one can have this type of phenomenon. One can have this type of phenomenon. This is called as classical physics. Under this macro physics, again there are several branches for there. Topmost branch is called as, what is the topmost branch? Whenever we say classical physics, one name is in general to utter. One name is in general to utter. What is the name? You can see on the screen. What is the name? It is mechanics. It is mechanics. In another words, there was a notion prevails among the scientists that classical physics and mechanics are two parts of the same coin. Two parts of the same coin. One side it is classical physics and another side it is mechanics. In another words, one can study only this mechanics in classical physics. This classical physics includes not only studying about mechanics but also studies about various vivid parts of energetics. For example, I gave only one there, thermodynamics. Thermodynamics. What is thermodynamics? What is thermodynamics? What it is related? It is related with what? What? Come on, tell me.
Energy, sir.
Okay, what type of energy?
Mechanical energy.
What?
Mechanical energy.
Oh, of course, mechanical energy only. Can you give any specific name, my boy? Of course, mechanical. Can you give any specific name? Thermodynamics we will call.
Inertia.
Inertia is the thing which is related to mechanics. I am asking about thermodynamics there. Okay? Any guesses please? Thermodynamics. Thermodynamics is a branch in which we study mostly about heat. Mostly about heat. In the branch of physics which deals with the heat energy. Heat energy. That is called as thermodynamics. Likewise, we come across many numerous branches under this heading called energy. Basically, the first one is energetics. First one is energetics. In the energetics, basically, firstly we will learn about acoustics. Do you know what is acoustics? Acoustics is a branch of physics which studies about sound and its propagation. Sound and its propagation. This is called as acoustics. Again, we will have likewise optics. We will have. What is optics? Any guesses? Any guesses for that? What is optics? What is optics? What is optics? Any guesses for that? Again, you will. Okay, take the mic and speak. ask for government facility so that the session will become more.
About light and visibility.
Yes, accurately. Give a huge applause for this point. Okay. Optics is that branch of physics which studies about light energy. In the local parlance, in the what you call in a formative manner, we call it as light. But when once it comes to the sophisticated language of physics, that terminology is read as optics. Okay, which is the toughest one. When we class, can anybody see the light? Can we? We have to experience the sun. We cannot see the light, but we have to read much about that light. Okay, so this is optics. Likewise, we have electricity, we have magnetism, many more number of branches of physics under this classical physics. This is one side. Up to 20th century, same type of phenomena was circulating in the minds of this physicist, the person who made research, the scientist who interested in physics, called as physicist. Today's topic mostly based on this astrophysics. Any guesses for that? What is astrophysics? Can anybody tell? Pass the mic. Those who are raising the hand. Pass the mic. It is better if you close that door. Guys, close that door also. It is effect of lighting will be there. If you are unable to close it totally, close to some extent. Okay. Any guesses? What is astrophysics? Okay. Pass on the mic. Raise the hand so that volunteers will come and assist you.
Related to space.
Yes, of course. It is answer nearer to the king. It is related to space. Still any more accurate definition? Okay, tell me. Pass the mic here.
Study of outer space.
Study of
Outer space. Outer space.
outer space. Okay. Nearer to the definition. See, many things were complex here. One cannot say this is only the accurate definition. What is you? What I give, that is only the particular constant definition. It is not like that. There are some complex words. In physics, there are complex words. Astrophysics is also one of the complex phenomena. What is meant by astrophysics? In the next slide, you come across that. I will tell. I am just giving a name the sun. In the next slide, you have the detailed explanation of what is astrophysics. Okay, just to maintain the tempo, I am giving that. Under this same heading, again we have neurophysics. Neurophysics in the sense nuclear physics. In this era also, we had our own history. Recently, here and there, you listen the news that there will be atom bombs, missiles, all such type of things will be there. How they are conjured? They are conjured with this nuclear physics only. Nuclear physics meant to create an enormous amount of energy. But unfortunately, the amount of energy which is released by, there were two processes in the nuclear physics. One is nuclear fission, another one is nuclear fusion. In both the processes, you have excess amount of heat energy. Excess amount of heat energy will be released. One cannot withstand to that high temperature. Whenever there is a nuclear reactor is established, surrounding area seems to be evacuated. We have our own era, our own lion's share in this nuclear physics. Finally, we have the last thing called as cosmology. There is a slight relation nearness between this cosmology and astrophysics. Cosmology is the thing which studies about the heavenly bodies or objects, Milky Way, etc. Okay? So I hope you enjoyed the classification tree of physics. Okay? Got the idea? So it is all about classification of physics. Next slide, please. One can see the, just observe the AV, another click please. Two AVs were played on the screen, just observe them. Two AVs were played, just have a glance on them, observe them. Any guesses for them? What is happening in these two slides? Any guesses for them? What is going on there? Can you tell anything about it? Can you tell anything about it? Any guesses for there? Can you tell anything about? See, in one of the slides, a person is sitting. What is he doing? What is he doing? Observing what? After something else. He is observing the sky. In the other AV also, you can see a group of people observing the sky. What is the time? What is the time? Day or night? Yes, it is night. Why it is night only? Any guesses? Any guesses why it is night only? Why it is night? I will tell you. Since ancient times, man found to be curious about sun, star and other celestial objects. Man found to be curious about sun, star and other celestial objects. These celestial objects called as heavenly bodies. You do remember this name? I will explain this heavenly body. When night falls on him, the mystery of moon hunts the human race. He starts exploring about space. When night falls on him, human race found to be very much curious. Human race found to be very much curious. Human race found to be very much curious, anxious about him, about the happenings of night. About the happenings of night. Okay? Like this, it will the phenomenon. One can see the man watching the sky. In another way, one can see a group of people watching the sky. Why this is happening? In the ancient times, till today, since ancient times to till today, man found to be very much curious about space. Man becomes mad on seeing the moon. In those days, the shining moon made the present topic of today's symposium as what designated to be satellite or ISRO. Satellite or ISRO. One can see the beautiful view of a satellite. Beautiful view of a satellite. One can see another AV, One can see another AV. Two things were there. Okay, my appeal is those who are going to watch that exhibition, go silently please. Go in a silent manner. Okay? So that it will be easy for me to give the presentation. Here one can see two different kinds of photos. In one you can observe one thing, in another you can observe another type of thing. Can you name them? Any guesses? Can you name them? Two things were there. One is this one, another one is that particular photo. Both are one and the same. At least tell me this one. Both are one and the same. Same or not? No. What is this one? What is the other one? Yeah, you are following. It seems to me you are genius. All the children who gathered here are going to be very much genius. Okay. So in one side you can see the rocket, another side you can see what you call satellite. There is a major difference between a satellite and a rocket. Major difference between a satellite and a rocket. What does a satellite consisting of? What does a satellite consisting of? One can see the separation core. We call it as a separation core. We call it as a separation core here. Separation core. Okay. Now let me indicate you what actually a satellite is. What actually a satellite is. You can find the answer. Satellites are of two types. What are they? Natural satellite and artificial satellite. Okay. Natural satellite and artificial satellite. Like this, there are two satellites for this. What is satellite again? Satellite is a body that orbits around a larger body. That orbits around a larger body. Satellite is a body that orbits around a larger body is called as a satellite. Mostly the larger body is stellar object or celestial object. Stellar object or celestial object. Those who are coming, come and occupy the place, sit silent. Okay? Silent. The presentation will be keep on going. So find your place and sit calm and quiet. Enjoy the session. So there are, what is a satellite? Now one can have how many different types of satellite in here? What is the classification? What is the classification? These satellites have been classified into two ways. One is human-made, another one is natural satellite. Natural satellite. Natural satellite in the sense, again is exceptional and everything. It's not to explain anything. They are natural. They are not man-made. They are made that's all. Again there is a great history, great scope to learn about this naturality of the satellite. That is separate here, separate thing again. So classification here goes as natural satellite, human-made satellite. Under this natural satellite we will have planets, moon, all stars, etc., etc., etc. The body which revolves other body will naturally become a satellite. Naturally become a satellite. Okay? You can become a satellite or you can become your own orbit. Suppose you are rich enough, everybody starts revolving around you. Nothing but the other fellows who revolve around you will become as a satellite to you. Will become as a satellite to you. Okay? Now again, what? Again we will have human-made satellite. Actually speaking, today's symposium on this human-made satellite. Human-made satellite. Why? Because the symposium itself aimed at launching of a satellite. Launching of a satellite. Do you know why this has been conducted by this IIITDM? Any guesses were there? Why this has been conducted? Why this seminar is conducted? This Professor Chandrasekharan sir, who is roaming here and there, had done what you call rigorous work, and his team, that one Mr. Shivankar, Gayatri, and other personnel who are moving here and there, underwent a great what you call rigorous work. They put hardship to have this. Why this has been arranged? Simply arranged for the sake of time pass. Idea of this geostationary. Geostationary in the sense, satellite is not stationary. A satellite will never be an ideal object. A satellite will not be stationary. What is the other name for stationary? Stationary in the sense, which is at motion or at rest? Stationary means rest or motion? Rest. Can you imagine any satellite will be at rest? What happens if a satellite is at rest? We cannot imagine at all. It has to revolve. That is the main work, and that is for that purpose only it has been designed. Here we are saying it as geostationary. Geostationary in the sense, satellite will be revolving. My dears, listen carefully. Got the point? Geostationary in the sense nothing stops here. Nothing is stationary. Revolution of the satellite is going on, but the revolution of the satellite is going on confined to a particular orbit. That is the meaning involved here. I think you got the point now. Why it has been named as geostationary launching vehicle. Got the point? Cleared all the assumptions. Geostationary launching vehicle in the sense it has been regarded as its orbit is stationary. That means that satellite is confined to move within the boundary of that particular orbit, that particular planet, that particular sun, that particular star, that particular moon. Like this we will call. This is the idea, this is the meaning involved in this geostationary launching vehicle. I think you got the point. Now you got the point. What is the major difference between GSLV and GSLV away? Both are same. One stands for geosynchronizing, another stands for geostationary. Stationary in the sense nothing is stationary. When stationary is there, that word doesn't meant for human race. What I say. Whenever it is stationary, you become lazy. Whenever anything you take, if it is stationary, it becomes lazy. So what my sincere appeal is, don't become a stationary object. Don't become a stationary body. Always try to be dynamic. Always try to be in motion. In the words of physics, there are only two positions for a body. One position is, you take any body, any object which is existing in the universe, either it is known to us, unknown to us, whether it possesses life, it won't possess life. There are only two positions, two states of a body. One is rest position, second one is so motion position is needed. In all aspects of our life, one should have this motion position. One should be dynamic. The body which tends to move, then dynamism follows it. So we learn dynamics also, we learn kinematics also. These all things were nothing but related to motion of objects. Motion of objects. So be dynamic in your studies. Okay? So this is all about GSL. Next thing. PSLV, Polar Satellite Launching Vehicle. Polar Satellite Launching Vehicle, PSLV. This orbits the Earth from pole to pole. I said earlier, many number of things were self-explanatory in physics. PSLV, Polar Satellite Launching Vehicle. As the name given as polar, it orbits the entire Earth from pole to pole. Pole to pole. Scans the entire Earth's surface during its orbit. How much time does it take? Any guesses were there? Any guesses? It takes one sidereal day, we will call. In the terminology of astronomy, we call it as PSLV day or called a sidereal day. Sidereal day is nothing but one day. Only in the sense 24 hours. It takes 24 hours to revolve around the orbit. Nothing but from North Pole to South Pole. North Pole to South Pole. Again from South Pole to North Pole. It takes 24 hours of time. That is called the orbiting capacity of this Polar Satellite Launching Vehicle. Main purpose of them is these Polar Satellite Launching Vehicles were generally meant for remote sensing, weather forecasting and mapping. That one word is wrongly spelled there. I think you might have noticed, right? It is a mistake. N to be there, but abruptly it has gone M there. So remote sensing, weather and mapping purposes. What is meant by remote sensing again? What is meant by remote sensing? Remote sensing is again self-explanatory. Very remote things can be sensed, can be perceived, can be viewed by this satellite. The things which are some hundreds of kilometers below the Earth can be very easily captured by these remote sensing satellites. Another one is weather forecast. When there will be rain, when there will be huge wind blow, all such type of things will be known. All weather forecast will be known. by using this PSLV. Again we will have mapping. Thank you. What is this mapping? Can you know anything? Without knowing that particular thing, we are very much conveniently we are using nowadays. Nowadays we are totally dependent on this mapping. What is this mapping? Any guesses? Any guesses, my dear young friends, young astronomers? What is this mapping? What the idea you have about this mapping? What the idea? Mapping. What do you meant by mapping? Very frequently we will use this word. Very frequently we will use in everyday life. Mapping. Suppose you are started from your home. You don't know this venue. What will you do? What the general tendency what we follow nowadays? You go for Google map and find out the location. Is it not mapping? Is it not mapping? Exactly that work is mapping. This mapping is possible by this PSL, Polar Satellite Launching Vehicle, which scans the entire Earth from pole to pole. It captures all the location data and sends it to different ways and means so that we can share the location. Very easily, very conveniently we are using this. Even a layman using this, interface now. He is simply standing elsewhere and sending his location so that his friends, like whatever it may be, a family, they can meet him, they can approach him very easily. Whenever we go to any new place, we are scared of new things. When once we are scared of new things, new ways and roads, then simply we take the help of Google Map. We share the location. Otherwise, our well-wisher will share the location to us, such that we can very easily reach that venue. Isn't it? This is all possible because of this PSLV launching vehicle. The main purpose of this PSLV launching vehicle is your mapping. Okay? One can see here. Now friends, let me inculcate you how actually a satellite launches. Major difference between a rocket and a satellite. What you are observing on the screen, is it a rocket or a satellite? It is a rocket. What is the difference between rocket and a satellite? Rocket is the one that is designed to propel a payload. Rocket is the one that is designed to propel a payload. Whereas satellite is one that orbits around the celestial objects. In another words, we can say that this rocket, for easy terms, for easy way of understanding, this rocket is a payload which consisting of a satellite in it. After covering certain distance, after moving quite away from the launching pad, it successfully sets that satellite into the orbit. So that is the difference between a rocket and a satellite. A rocket is nothing but a payload. Whereas a satellite is the thing that orbits around the celestial bodies. Remember, a rocket never orbits anything. It only skies high. It jumps into the high with a greater speed. Okay. Many number of times we will be seeing here and there. Here also we can see here the thrust of the rocket will come. The engine has been ignited and the rocket rising up. It is reaching the sky high. Next.
You are writing. Where is your writing?
Here is there.
Where? You are taking phone.
I think it is more than an hour that I am giving away the presentation. So I feel to be thirsty, rather I will be excused for this. One can see here, what is the roaming there? Is it a rocket? I think you got Well understood now. What is the rocket and what is the satellite? Got the point? What is the rocket and what is the satellite? The revolving thing here. The thing which is revolving here is nothing but a satellite. The satellite, how one can perceive the satellite revolving around the earth. This is the satellite which is revolving around the earth. Okay? There is a slight difference between rocket and the satellite. A satellite is the body which orbits any other celestial body. Don't think that it is revolves around earth only. It revolves around moon. If there may be satellites which revolves around some of the stars, there are some satellites which revolve around sun. Like this will be the phenomenon. Okay? So this is the satellite. In the AV, what is shown is a satellite revolving the globe. Entire globe it revolves. Whenever if it is a satellite, remember that it is not meant for a single country, not meant for any particular region. Why? Because it is quite away from the Earth's atmosphere. In the space it is. Henceforth it captures the entire globe. Entire globe. Just now we come across the PSLV. PSLV in the sense polar satellite launching vehicle. Nothing but which scans the earth from pole to pole. Okay? So that is the idea here. One cannot confine its jurisdiction. One cannot confine its jurisdiction. One can see the significant move of a rocket, significant move of rocket or a satellite. Significant move of a satellite here one can see. Next thing. Okay. Here one can see what actually a satellite consisting of. We have seen a satellite is orbiting around any celestial object. Let us suppose Earth. Earth is known to us. Why? Because where were we? Where were we? On Earth or on the moon? On Earth only. So we are simply take this as an example, an analog. An analog has been taken. Initially, there are two stages in launching a vehicle. Initially, there are two stages in launching a vehicle. Up to this, we studied briefly about what is a satellite, how many type of satellites will be there, what are the things. These are all things we study. Actually, we are entering into launching now. What are the primary requisites for launching a satellite? There are two stages in launching a satellite. First one is to obtain escape velocity. A satellite or a rocket have to obtain escape velocity. When once a celestial object, when once a satellite obtains escape velocity, then only it can got to obtain orbital velocity. Escape velocity is in the sense of 11.2 kilometers per second. Remember, it is not per hour. If it is per hour, not a satellite, even a vehicle doesn't go that much fast. What is the fast that we will go on a vehicle? Minimum, younger generation will move at an average speed of 50 kilometers. Very fastly they will be driving the vehicle. Till today I can't understand what urgency pushed them to go such a speed. There were many accidents, my dear. Many of my students were passed away. And it seems to be fascinated to them. It becomes a passion that whenever we ride a vehicle, we go with 80, 100, 120 speed. What is the use? When any urgency is there, when you are going to donate a blood, when you are going to rescue a man who is drowning into any sea or ocean or a river, then you can go. Then there is a meaning. What is the meaning involved? Every time you are moving with 190 speed, what is the meaning there? Even a small mistake, a split of the second can cost the death. So my sincere appeal to the elder generation, coming up future citizens of India, whenever needed, utilize. Why? Because the basic design of the vehicle which we are drawing is meant to obtain the speed, no doubt. But every time speed is not comfort. Every time once you ride the vehicle, you go by 100 kilometers. What does it mean? Can you tolerate? Imagine that speed was. We can't tolerate. Our vehicle was not designed to tolerate that speed. mainly our roads were not designed to stand that much speed. Remember, even a vehicle may be designed, but our roads are not up to the mark, my dear. That is the poor fate of we people. Still after getting independence, more than 75 years, but roads were not constructed in such a manner that a person can move on a vehicle with a speed of 100 kilometers constant. To a little extent, one can go 100 kilometers safely. Beyond that, we may not find him on the road. We find him in the sky. I will assure you. So, my sincere appeal, as the time came, even though this is not part of the seminar, I suggest you not to go very fastly, not to drive any vehicle very fast. Again, coming to this escape velocity, which is a prime requisite, plays an important role. It takes a pivotal role. It is the lion's share in launching a vehicle. Escape velocity. Escape velocity is again self-explanatory. What do you mean by escape velocity? Escape, self-explanatory. Escaping. What did escape? What did escape? What did escape? When our class is there, simply we escape from the class. That is the general routine, isn't it? If the class is not interested, we simply escape. Like this. Here also, this payload, a rocket which has been launched, a satellite which has been launched, escapes the earth gravitational pull. Escapes the earth gravitational pull. How much will be the earth gravitational pull? Acceleration due to gravity, small g. It is termed as small g. It is 9.8 meter per second square. Meter per second square. Any object, any body which wants to revolve, which wants to move high, means it has to overcome this acceleration due to gravity. The gravitational pull of the earth can be escaped. So that velocity only can be obtained by moving an object at a speed of 11.2 kilometers per second. When anything, any vehicle, even if you or me obtains this velocity, we cannot stand on the ground. We cannot stand on earth. We will be floating. We will be floating. But because to this speed, to this velocity, to this acceleration, one body doesn't stand on earth. It overcomes the acceleration due to gravity. So this is called as escape velocity. Escape velocity. V is equal to how V is equal to capital G capital M by small r. How it has been derived. In the simple term, in the simple steps, I will show you the entire derivation. I will make sure you to know this derivation. Okay, it requires a centripetal force to keep on rotation in an orbit. It requires a centripetal force to keep on rotation of an entire orbit. What do you mean by centripetal force? Centripetal force is that force which makes the body to rotate or revolve for both the purposes. When anything is rotating, anything is revolving either on the or in the space. Remember, it is nothing but it is the virtue of byproduct of a physical quantity called centripetal force. Centripetal force is that force which constantly changes the directional velocity, not the magnitudinal velocity. Magnitudinal velocity remains constant, whereas direction of the velocity gradually changes. The type of velocity, the type of force exerted on the body is called as centripetal force. Centripetal force in the sense is also called as center seeking force. Center seeking force. As this force plays a pivotal role, then only there will be a force of attraction between a satellite and the stellar body, and the celestial body, and the celestial body. Let us suppose any satellite is revolving around Earth, then there will be a centripetal force which binds between the satellite and the Earth. Okay, so that is the centripetal force. Thus we will have centripetal force. F equal to mv square by r. Fc is equal to mv square by r we will have. On equating the forces, we will have Fg is equal to Fc, where Fg is gravitational constant. Gravitational constant force Fg. Fc stands for centripetal force. On equating both the forces, where once we write their formula, we comes like this: capital G capital M small m by r square is equal to mv square by r. This mv square by r is nothing but centrifugal force. I request the audience to be calm and quiet. To be calm and quiet. Session is coming to an end. It is more than 1.5 hours that I am constantly giving this lecture. So my patience also there. I think of my patience. It is very difficult. I am a man of half century. I crossed the half century. Okay? It is very difficult for me to stand for a longer time. So if you arouse anything, it will be a difficult, it will be a hindrance for me. So any work is there, do that one silently. Pay attention towards the seminar. So capital G, capital M, small m by r square is equal to mv square by r. Where small m this side, LHS side, RHS side, small m will be get cancelled. And cross multiplication we will have capital G, capital M, R is equal to V square into R. V square into R square. That we will have interchange the terms. LHS becomes RHS, RHS becomes LHS. That is pretty note to you people rather than me. Because you are studying math. Nothing will happen. That implies V square is equal to GMR capital V capital M small r by R square. Where R will be just cancelled, in the denominator R remains. V square is equal to capital G capital M divided by small r. That implies V is equal to square root of Gm by R. Nothing. We got obtained the first derivation. We got obtained the first derivation. Its value found to be 7.3 kilometers per second. Orbital velocity. Okay. Now one can see how a rocket launches. What does it consisting of? How this launching mechanism takes place? Rocket mostly consisting of different chambers. These chambers filled with propellant. What do you mean by a propellant? Propellant in the sense it is called as fuel. Propellant in the sense it is called as a fuel. What does this propellant or fuel consisting of? This propellant or fuel consisting of liquid hydrogen, kerosene and oxygen. Liquid hydrogen, kerosene and oxygen. These three were the main fuels. Fuels in the sense propellant which will be used in different chambers. When one of the chambers were ignited, an enormous amount of center. I was telling something that one cannot find the photograph. Why? Because it is totally related to our security system, our defense system rather. So nobody is permitted to take any sort of photograph there. Even the persons who are working here, they cannot take the photograph. It is highly a confidential work. Entry also restricted. I will tell in the due course how to enter there. Okay? Next please. See, ISRO, SHAR or SDSC, Satish Dhawan Space Center is located near Sulurpet. It is a proud factor for we the Andhrites. We are all Andhrites, isn't it? Of course, we are Indians, no matter. There is no other word for this. But even in India, we belong to Andhra Pradesh. We are Andhras. It is a proud factor for us. One have to feel proud. One have to take a proud breath that this ISRO has been placed near Sulurpet, erstwhile Nellore district. Erstwhile Nellore district. In the sprawling 1,000 acres of land at seashore. This point you remember. You remember this point? At the seashore this following 1,000 acres of land has been allotted for this ISRO and for all these activities. Now the question arises, there were many cities, even Hyderabad, that is a great metropolitan city is there, even Mumbai you take, even Kolkata you take, many cities were there, Uttar Pradesh you can take, Jammu Kashmir, heaven on earth we call, that place is there. Why can't we choose that place? Why can't we choose that place? Any guesses for that? Any guess? Why can't we choose any other place in India except this place? Why you choose this place only? Why scientists astrophysicists chosen this place only? What might be the reason behind this? The reason behind this, I do not know. Before I spend there, before I go there, I do not know why this has been, this place has been taken. To my merit, I spent more than 48 hours of time in ISRO in the year 2000, in the Millennium Building. They only invited me. They only invited me as what I invited today by this IITDM to give a beautiful symposium in a very synchronous manner. Today, likewise, in the beginning of the millennium, in the year 2000, in the month of August, I spent more than 2 days there on their invitation. One cannot go there. If you want, if you will, you cannot go there. It is not in our hand. We have to do correspondence or we should have to be invited. To my merit, to my credit, I got consecutively 3 state awards. Consecutively, I had a hat-trick. Consecutively, I had a hat-trick of awards. 3 years consecutively, I obtained state awards. I think you people will be knowing there will be scientific, science seminars and science projects. Shows will be there. I went there along with my children, and each time in the year 98 in Kurnool itself, in the year 99 at Gudiwara, in the year 2000 at Hyderabad, state science fair, my models, my projects were get selected. So as I got a hat-trick, I was invited by ISRO. I was invited by ISRO authority to know about the facts and findings of ISRO. Really, it is a wonderful place, an amazing thing to spend there. To spend there, one can see how our scientists will work. Okay, so that is the merit. I was fortunate to visit there.